Side circuit of the transformer by referring secondary side parameters to primary side, and this is the simplified circuit of the two winding transformer by referring primary side parameters to secondary side. First we concentrate on this by referring secondary side parameters to primary side. Through this simplified circuit, how we can draw the vector diagram. As we know, this load may be purely resistive, purely inductive, purely capacitive, or inductive, which is combination of resistance and inductance, or capacitive, which is combination of resistive and capacitive. In general, overall load is generally inductive. How to draw the vector diagram for inductive load? First of all, you start from load side and move to supply side. Take a horizontal line whose magnitude is equal to this V2 dash. This much is V2 dash. Now, since load is inductive, hence this current, load current I1, will lag the load voltage V2 dash by a certain angle less than 90 degree. And this is load power factor angle phi 2. Now, this V2 dash and this voltage drop in winding resistance I1 into R01 will be in phase with I1 and will start from this V2 dash point. In parallel with this I1, but its magnitude will be product of I1 and R01. Then voltage drop in this, as we know, this is in quadrature, J means 90 degree. In quadrature with I1, hence in anti-clockwise direction at an angle 90 degree. This angle is how much? 90 degree, and this value is I1 multiplied by x01 in the direction J. This voltage drop has been added, and the final point, this initial point, this is the supply voltage V1. And angle between V1 and I1, this angle is supply power factor angle. The vector diagram is complete, very simple. Similarly, for inductive load, by referring primary side parameter to secondary side, start the vector diagram starting from this load side V2 and this load current I2 lagging behind the load voltage by an angle I2, load power factor angle. I2 into R02 will be added in this V2, whose line will be in parallel with I2. Yeah, I2 multiplied by R02, and product of I2 and X02 will be in quadrature with this line in anti-clockwise direction 90 degree. This value will be I2 multiplied by X02 in J direction, and this final point and this initial point is supply voltage V1 dash. If the load is capacitive, this I1 will be leading this V2 dash in this direction, and I1 R01 will be in this direction. I1 X01 will be in this direction, and the final point, initial point, will be joined to get the value V1. For purely resistive load, I1 will be in phase with V2 dash in this line. I1 R01 will be in this line. I1 X01 will be here, and meeting point of these 2 points will be V1. Similarly, for purely inductive load, I1 will be lagging behind this V2 dash by 90 degree, and same process will be repeated for purely capacitive load. I1 will be leading from V2 dash by 90 degree in this direction. I1 R01 will be in this direction, I1 X01 will be in this direction, and the meeting point of these two will be V1, and same process will be repeated for this also. These are the methods to draw the vector diagram. From this vector diagram, we can calculate the voltage regulation and many other parameters in a very simplified way in the next session. Thank you.